Hello students, welcome to EduCell. This video we are going to solve a recurrence relation using iteration method. Those who are new, kindly check the detailed lecture video I have uploaded. Now we should start with it. So the value as for this, the base condition is written where t is 0, t of 0 is 0 means where n value is 0, we can say the cost is 0. You can write the base condition as this is our base condition. Okay, t of 0 equal to 0. You can write it n by 2. Then only what we found t of n, an unknown variable is also added, or unknown function. The value of that function is, if you want to find, so put the value like n minus 1 in place of n, then only you can expect some result. Okay, so here I want to write 1 minus 1 minus 1 is minus 2, next n minus 1 by 2. This is how we are getting. But iteration, we are going for 1 iteration. After that we substitute to get a proper value. So substitution is like you are going to check for the variability, like to like you can say, you have to go for a proof. Whether your proof is less than, the detailed video is there, you can go and check. The tricks I'll tell you after this, after the iteration method which we are going to discuss, or and the master theorem also I'll tell you the method to find, to go for a proof. Okay, I'll tell you the tips and tricks about it. Now for this, t of n by 2 is also unknown when we are finding the n by 1. Then n minus 1 is this one, so n minus 2 if you're finding, so put the value there in n. When you're finding this, so in place of n you're putting n minus 2, then minus 1, then n value is there, that to be this one. Clear? If you want to simplify, it would be like this. Okay, n minus 2 minus 2 by 2. Clear? Next for t n minus 3, I'm just going for further to make it more simplifying, like 3 minus 1, that I'm putting the n, you know, in here, n as well as here. Clear? So the same case you can say. Clear? Then only we are getting the value tn minus 4 by tn by 3 by 2. Clear? You substitute directly, but this iteration is not equivalent to substitution. I'm repeating again. The detailed video is there. Okay, so tn minus 1 n by 2. Clear? Then you substitute the value of tn minus 1. The tn minus 1 value is tn minus 2 plus n minus 1 by 2 plus n by 2. Clear? Next is the value of tn minus 2 is tn minus 3 plus n minus 2 by 2 plus n minus 1 by 2 plus n by 2. Clear? You can say it's 0 also, not an issue. N minus 1, like 1 0, you can go for it, not an issue. Next is the value of t n minus 3 is, as for this, is t n minus 4 plus t n minus 3 by 2 plus n minus 2 by 2 plus n minus 1 by 2 n by 2. Clear? Next, though you found it, so let us go for running of k times. Running for k times. Somehow we are finding a pattern. Okay, running for k times. When you are running for k times, that could be written as or rewritten as. Suppose n minus k I am writing. If you are deciding this 4 value is k, na, so 3 is there. So immediate will be n minus k minus 1 by 2. Next immediate will be 2, which is 2, 4 minus 2 equal to 2 we are getting. So like that we can write k minus 2 by 2 up to that n minus 1 by 2 plus n by 2. Clear? That is too easy now. Next, though we reached somehow condition, we think we are assume that we have reached the base condition, because I told you in the detailed video, we are switching towards the base condition. The main reason is we know the value of base condition. We do not know the value of other conditions. That's why we are reaching towards base condition to simplifying it. Like you are unknown to a particular problem. When you are reading it, you are trying to correlating with which you have already understood. Like which you understood, you try to correlate with it. Means you are reducing to the point which you understood. This is what we are reaching towards the base condition. Okay. Next is when we are reaching the base condition, as per the base condition, it is written like t of 0 equal to 0. Okay, t of 0 equal to 0. So as per the base condition, we reached our condition is this one. We reached t of 0. Then we are substituting the cost there. As per the cost, our target is how many times it is running, k times we are running. So the value of k we are needing then. We are substituting the value of k. Once we are substituting the value of k, you can say you can directly put t of 0, or else if you do not want to put, you substitute the value n minus n will be 0 then. So t of 0 I am directly writing because we reached the base condition. Next, n minus in place of k, you can write n because you are substituting the value of k. Better I am just writing here substituting the value of k. Clear? Next, t of n would be t of 0 plus n minus 1 by 2 plus n minus n minus 2 by 2 plus n minus n minus 3 by 2 up to n minus 1 by 2 plus n by 2. Clear? Next, t of 0 is 0. So you ignore that constant. Now you focus here. 0 I'm writing plus n minus n plus 1 by 2, n minus n plus 2 by 2, n minus n plus 3 by 2 up to n minus 1 by 2 plus n by 2. Next is 0. N got cancelled. Clear? So it's 1 by 2 plus 2 by 2 plus 3 by 2 up to n minus 1 by 2 plus n by 2. Clear? So here to simplify it, I'm just omitting 0. T of n would be like 0 plus 1 by 2. Clear? We have just taken 1 by 2 outside, plus 2 plus 3 plus 4 up to n minus 1 plus n. That we know the summation of n is, you can say 1 by 2 I am keeping outside, it's n into n plus 1 by 2. Clear? 1 to 10 if you are counting 1 plus 2 plus 3 plus 4 is 10 plus 10 into 10 plus 1 which is 11 by 2 which is 55. If you want to count the value that we have already studied in the mathematics, that could be like 0 plus, like 0 is from the cost that we have got. Next, n square plus n by 2. So after that, the time complexity, the maximum will be the time complexity. You can simply write time complexity as equal to big of n square, or big of n square plus c, big of n square plus n divided by c. Anything could be possible, but n square, though it's maximum, that's why we are saying it's n square. If you'll apply the master theorem also, you'll get the same answer. Next videos we are going to discuss about the master theorem, solution of master theorem, and tricks for substitution method. Thank you for watching the video. Have a good day.